The right sequence of prompts combined with your unique domain knowledge is an entire 5, 6, or 7-figure product in itself. In this video, I want to dig into 7 prompt chains with real examples you can use to level up your prompt engineering ability to build better products, tools, and applications. The name of the game in software now is how can you build agentic software that creates value on your behalf for you and your users. I've got 7 prompt chains I want to show you that can help you achieve that goal. Let's start with the snowball prompt chain. We're using Claude 3, Haiku, Sonnet, and Opus models, and we're passing one or more of our models into our prompt chain examples. The snowball is a really interesting prompt that allows you to start with a little information that is slowly developed over each prompt. Let's look at the mermaid chart to see exactly how this works. So you start with base information, then you run 1 to n prompts that gather and create information based on your original information. With each prompt, the context improves, and then finally you run a summary or format prompt that finalizes this AI agent's run. So let's look at a real example here, right? I have this base information, 3 unusual use cases for LLMs. I'm passing it into this prompt where I want to generate click-worthy titles about this topic. And that's our base information. So from this single prompt, we're having our model respond in JSON format where it's going to return a click-worthy title and our topic. And that's going to create our first snowball. After we have that, we ask it to generate a compelling 3-section outline given the information. And you can see here, we then repeat the pattern. Right now we have the title, the topic, and the sections. That creates our second snowball of information. You can see where this is going, right? You can basically just continue to do this and add arbitrary information over time while keeping each prompt specialized to generate one thing. It's really important that you treat all of your LLMs like individual functions with concrete inputs and outputs. That allows you to fine-tune and tailor each prompt to solve its problem the best it possibly can. So let's run our snowball prompt and let's see what we get. So you can see we have our first snowball, second snowball, and then finally we're getting content. And then lastly, we put it all together in a combined markdown blog. As you can see at each step, the LLM is adding information. It's literally enlarging the context of the problem that we're trying to solve. At first, we only have a topic, we pass that in, and the first snowball is created, giving us a topic and a title. Then it creates sections, then it creates content, and then finally, we put it all together into a final cohesive markdown blog. And you can see here, we're writing that all to a file. We can go ahead and take a look at this file here. And the best part is, of course, it's completely reusable. This is a really powerful, interesting chain that's really great for writing blogs, building newsletters, doing some research, writing summaries. And just a note on the terminology here, prompt chaining, prompt orchestration, prompt graphs, they're all referring to the same idea of generating concrete outputs by combining LLMs, models, and code together to drive outcomes. So this is one way you can drive a specific set of outcomes. Let's move on to our next prompt chain. This is the worker pattern. So you've definitely seen this before. It's a really popular pattern in research tools. So it's likely you've heard of GPT Researcher or something similar. The worker pattern is one that is really popular when it comes to doing research, putting together ideas, making web requests, and then doing research based on the response of the request. You can see here, GPT Researcher is doing something really similar. They have a task, they generate questions, and then they fan out into individual prompts that then get combined into a final report. This is the most popular pattern for research type tasks. So let's go ahead and dive into this. I like to call this the worker pattern, where you basically delegate parts of your workload to individual prompts. All this code, by the way, is going to be in a really simplified GIST. There are a couple requirements. I'll put it all in the GIST. You'll be able to fire this up in no time. Link for that is going to be in the description. Here is what the worker pattern looks like. So you have your initial planning prompt. Then it creates n steps to be processed, or n items to be processed for each one of your workers. Your workers then individually and ideally in parallel run their prompts, and then they all funnel their results into a final summary or format prompt. This creates really, really powerful agents that are able to gather information on the fly based on your initial planning prompt, do research, generate content, generate code, generate whatever you're looking for, and then pull it all together into a finalized output. This is one of the most popular prompt chaining patterns, prompt orchestration patterns that's getting used right now, as the use cases are very obvious. Let's go ahead and take a look at an interesting example. So first off, we'll just go ahead and run this. So while this is running, let's go ahead and walk through the code. Just like you saw, we have this code planner prompt. All we're asking here is generate function stubs with detailed comments on how to write the code to build a couple of functions here. We're then giving an example of what exactly we want. And then we're saying respond in this JSON format where we have a list of function definitions, but not the full function, right? This is our planning step. After we have that, we then load out our function stubs from our JSON response. I highly recommend that you just default to using JSON responses. It creates a more simplified, consistent structure for all of your prompt chains. We then loop through each one of the function stubs, and as you can guess, we're then running prompts for each one of those function stubs and then combining it into a single large string. After we have that large string with all of the results, just like as you saw in our diagram here, all of these results from each worker prompt get funneled in to our last summary/format prompt, where we then clean up the code and combine it into a single final Python file that can be executed. We'll specify one more JSON format, and then we just dump all of that to files.py. So you can see here, we're actually using this pattern to build out entire file modules. So we're essentially using the worker pattern as a kind of micro AI coding assistant that can build out entire files for us with related functionality, right? In this example, we're building out a file writing module that allows us to, write JSON files, write YAML files, and write TOML files. All right, so let's see how our prompt has done. All right, awesome. So it's finished here. Let's go ahead and take a look at that file that's generated. So we now should have a files.py. Let's go ahead and look at that. And okay, so we have a little bit of extra here. That's fine. Let's go ahead and just remove these lines, and bam. So you can see here we have, let's go ahead and collapse everything here. So you can see here we have 3 really clean functions written out with comments and examples of exactly how to use it. This looks really good, and I hope this shows off the power of using your prompts to do one thing and do one thing well, right? We had our planner just plan the function stub, and then each worker actually wrote out each individual function, right? So you can be as detailed about how you want to write a function as possible, and then you just loop that over however many of those functions you actually want to write based on your plan prompt. So it really allows you to divide and conquer in the truest sense and really keep all of your prompts isolated. And then of course, the summary format, we can clean that up a little bit. If we Control Z, we had a little bit of extra here. This can all be cleaned up, as you know, with proper management of the prompt and the LLM. Let's look at a more unique prompt. This is one that I've built into a product that I am actively building right now. Let me show off the fallback prompt chain. If you're enjoying learning about these prompt chains or refreshing your memory on these prompt chains, definitely hit the sub, hit the like, helps out the channel. I think we're hitting 10K subs literally as we're filming this video. Huge thanks for everyone watching. Let's keep moving. The fallback prompt chain is really interesting. It allows you to run a prompt, an LLM, an entire model, and if something goes wrong with the process that runs after the prompt, it then falls back onto another prompt or model. Let me show you exactly what this looks like. So you can see here, we start out with our initial top priority prompt or model. This pattern allows you to do something like this. You can run your fastest, cheapest model first. You take the response of the prompt and you run whatever code or whatever process you have that you wanted your prompt to generate for you. If your process fails, you then run your secondary or your fallback model. You then run your process again. If it fails again, then you use your last resort, final, big, chunky, expensive model. But if at any point before that, your cheaper, faster model runs and succeeds, this AI agent, this prompt flow is just complete. That's the big advantage here. It allows you to run your cheapest, fastest prompt and model first. Let me show you a concrete example. So I built out this little function fallback flow functionality. I'm not going to dig into the code too much, but I just want to focus on the high level flow here for you. Here we're generating code. We're saying generate the solution in Python given this function definition. So we're just giving it a function definition. So we're saying text to speech, passing in text, and then we want to get bytes back. We're asking for the response in JSON format. And then look at what we're doing here. We have a list of functions where the first parameter of the tuple is going to be a function call to each Claude 3 model. So you can see here we're starting with our Haiku, cheap, fast, top priority model. We then use our cheap, moderate, secondary fallback model. And then at the very end, if all fails, then we use the Opus model. The key with the fallback flow prompt chain, prompt graph, prompt orchestration flow is that you need an evaluator function. right? And your evaluator is basically what are you trying to run given the output of your LLM, right? Given the output of each one of your fallback functions. And in this case, to validate our output, we can just run the code, right? And in actuality, this doesn't actually do anything. I'm just running this coin flip function here that's going to 50% chance return true or false. But you can imagine that you're actually running the code. And then if it's correct, you then proceed with your application. But if it's wrong, that's when the fallback function kicks in. So let me go ahead and just run this and show you a couple examples of what this looks like. So here's a fallback flow. So we've fallen back to Sonnet, we've fallen back again, and now Opus is running. There we go. So our Opus model was the final winner here. It looks like the code that generated is using it's using Google's text-to-speech module. That's cool. We don't really care about that. It's all about the prompt chain. So let's go ahead and run that again, right? Since this is a 50-50 random coin flip, we're going to be successful some of the times with our earlier prompt and fail in other cases. So let's go ahead and run that again. Bam. Okay. So you can see here in this example, if your first top priority fast cheap model worked, your flow is finished, right? There's no reason to fall back. So this is a prompt chaining framework that I built into an application called Talk to Your Database. This is a text to SQL to results application built to help you retrieve information from your SQL databases faster than ever. But you can see that pattern concretely used in the agent customization. If our caches miss, we'll then fall back on these customizable agents that generate your SQL for you based on your natural language query. And you can see here we first run Grok Mixtral because it's hyper fast. But if this fails, what we're going to do here is actually fall back to GPT 3.5, right? So a little higher accuracy, still got a lot of great speed, still really cheap. But if that still fails, say you're running a really complex query, it just gets the SQL statement wrong, it'll then just fall back to a big, beefy GPT-4 SQL agent. I've got it on the roadmap to add the Claude Opus model. That's probably going to be an even bigger fallback than GPT-4, given its benchmarks. I just wanted to show this off because this is a productionized example of how you can utilize the fallback flow. Inside the application, you can see this working in practice. So if I just run a random natural language query here, we'll say, let me open up the tables, we'll say products price less than 50. You can see this is going to return basically right away. Based on the simplicity of it and based on all the benchmarks I've run, I can almost guarantee you that this was the result of the Grok Mixtral model, right? So I just wanted to show that off in a real productionized concrete example. Feel free to check out Talk to Your Database. I'll leave the link for the app in the description. The app really only has one purpose, and it's to help you retrieve information faster than ever from your database. So that's a concrete example of how you can use fallback flow. The big win here is that it allows you to save money and save time, but you also increase the reliability and the accuracy of your AI agent as a whole, because if something doesn't work, it'll just fall back to the next available model and the next available prompt. And the prompt is also another dimension of this prompt chain that you can tweak. Maybe you'll have a longer, more detailed prompt and a more powerful model in your second or third execution of your fallback function. So this is another really powerful pattern that you can add to your agentic systems. Let's go ahead and keep moving. Let's talk about the decision maker prompt chain. This is a fairly simple one. We've done videos on a couple of these prompt chains in the past. We'll go ahead and kick this one off. So the decision prompt chain works like this. It's really simple. You ask your LLM to decide something for you, and based on those results, you run different prompt chains, you run different code flows. Let's look at a really simple example of how you can use the decision prompt chain. So it's really great for creative direction, dictating flow control, making decisions. You can see here we have a list of statements that you might find in a quarterly report from a company. Things like our new product launch has been well received by customers and is contributing significantly to our growth. And then other negative type things like the competitive landscape remains challenging with some competitors engaging in aggressive pricing strategies, right? So imagine you have a live feed of these statements coming in and you're analyzing it, and what you want your decision-making agent to do that's listening to this live feed, you want it to analyze positive versus negative sentiment. This is a really popular use case of making decisions on the fly, analyzing sentiment to make decisions on your behalf. This is a really powerful way, a powerful technique, a powerful prompt chain to utilize in your products. The sentiment analysis then responds either positive or negative. And then what you can do essentially is map the result to an action, right? So you can see here in this simple map, we have positive mapped to a function and negative mapped to a function. And then we have an unknown fallback method, right? And then you just call whatever your next step is, right? So this is us running, the prompt chain 1, prompt chain 2, prompt chain 3, whatever the next step is here. That's what this function map represents. And in this case, we're just saying, the following text has a positive sentiment, generate a short thesis about why this is true. Really, you could do anything inside your next step, your next action. That's really up to you and whatever domain or feature that you're working through. The power in this lies in being able to offload decision making into your AI agents. So you can see here, we analyze the sentiment here. We incurred higher than expected costs. This is, of course, is going to come through as negative sentiment thesis. And then it's just giving a brief explanation. The core value proposition here is to remember that based on the decision that your LLM has made, you can now run arbitrary code, arbitrary additional prompts. And this is where a lot of latent value of LLMs really exists. So let's move on. Let's talk about plan and execute. So this is one that you're likely to be familiar with. We don't have to go into this in too much detail, but this is your typical chain of thought, tree of thought, any type of planning first, then execute sequence of prompts will essentially get you to this result. Let's look at the diagram for this. In its essence, it's really simple. You start, you plan, then you execute based on your plan, and then you end. We saw a more concrete example of this in the worker prompt chain, but in its simplified form, it really only needs 2 prompts to run. First, you do your planning, then you do your execution. And just as a simple example here, we have a simple task. We're going to be designing software architecture for an AI assistant that uses text-to-speech, LLMs, and a local SQLite database. We then prompt our agent to, make a plan. We have this classic activation phrase, let's think step by step. There are several variants of this you can find all over online, but they all boil down to the same thing. Let your LLM think first, give it time to think. And in that thinking, it acts as a context builder, context formatter, kind of a memory arranger for your next prompt where you actually do the thing that you would have prompted originally in one shot. So let's go ahead and run this. Excellent. So you can see we have use cases, we have diagrams, we have components, we have an overview that's all running nice and clean. And then we have our output at the end. So the idea here, of course, is without the plan, the final output would not be as good. So I'll let you play with that. We don't need to dig into that one too much. That's a really popular prompt chain, just as this next one is. So let's talk about human in the loop. This is a simple one. Basically, it's any UI UX combination where you're running a prompt and then on some loop or via some UI, you are asking for user input, right? That's essentially what this pattern is. And we can visualize this with this mermaid chart where we have our initial prompt. We then ask explicitly for feedback. We run our iterative prompt and then give our LLM more feedback. And this runs in a loop until we get the result we're looking for, and then things finally end. So I'm not going to run this. It's pretty straightforward. You run your initial prompt. So here we're saying generate 5 ideas surrounding this topic. And then while true, iterate on this idea unless we type done. And this just lets you build up context, build up a conversation, build out concrete results over and over. It allows you to go back and forth. This brings us to a really, really important point about prompt chaining and building products. If you think about it, this single flow, prompt, feedback, iterative feedback, that flow is exactly what the ChatGPT application is, right? You're typing a message. This is your base prompt. It responds to you, and then you're saying something else, right? You're giving it some feedback. You're having a conversation. You're going back and forth. So it seems obvious to say it out loud, but I just want to highlight that this single prompt flow is an entire product. And it's like, yeah, of course it is. But I think it really highlights an interesting idea that we haven't really seen or have truly explored the full capabilities of LLMs by any stretch of the imagination, right? There have been so many products coming out that is just this. It's just the chat interface. This is something I mentioned in the 2024 predictions video. We're going to get so sick and tired of the chat interface. And at some point, someone's going to innovate on it and create something more interesting. There are definitely variants of this. For instance, in Talk to Your Database, there is a prompt results type of format, right? So we're not having an ongoing conversation here. In Talk to Your Database, you're just writing a natural language query, right? You're saying, jobs ID 5. And you have a bunch of agents running in the background that just give you the result you're looking for, right? So this is more like a call response type of prompt framework. And as I mentioned, behind the scenes, we're using the fallback prompt chain. But I just want to highlight that idea that there are so many applications being built with the chat interface, and under the hood, that's just one prompt chain. So there's so much innovation. There's so much to build. There's so much to create. I hope that this makes sense. And I hope that you can see, all the potential value that every one of these prompt chains has for us, right? The human in the loop is such a popular prompt chaining framework. And frankly, it's beyond overused, right? There are so many more creative ways to build out user experiences using different UIs, different UXs, but also any one of these other different prompt chains or any combination of them. That's the human in the loop. You've seen that one. You use it every single day when you interact with any one of these chat interfaces. Let's look at the self-correction agent real quick. I'm just going to talk about the code. I'll run it quickly. So the self-correction prompt chain looks like this. This is an idea we've explored on the channel before, but essentially you have your prompt, you execute based on the prompt. If it's correct, you're done. Your agent has completed its job. If it's not correct, you run an additional self-correction prompt, and then you end. And of course, your self-correction can take many forms. It can run in a loop, it can run over and over, but the idea is as simple as this: execute. If not successful, self-correct, right? And this is really good for coding, for executing, for reviewing. It's really great for improving on what's already been done. Okay, great. So this finished running. In this simple example here, we're looking for the right bash command that lets me list all files in the current directory. Super simple. Don't focus on that. Focus on the chain. The initial response is ls. Then we say we're running the command. I have this execution code. In this case, we're just doing another coin flip, and then we're saying, mock error. So we're just kind of pretending like there's an error. The core idea here is if your execution on your original prompt causes an error, you then run a different code flow that self-corrects the previous run, right? So you can imagine if you're doing something like generating SQL, or you're generating code, or you're generating, something that is executed against a functioning system, aka any function, you can use this pattern to self-correct mistakes. We did an entire video on this. I'm going to link all the videos where we've covered some of these topics in more depth in the description, as well as all this code. I'm going to throw this in a GIS, so it's really simple to look at, really simple to consume. But that concludes 7 prompt chains, prompt workflows, prompt flows, prompt graphs, prompt orchestrations, whatever you want to call it. That concludes 7 prompt chains that you can use to build great AI agents, powerful agentic systems, and new and interesting ideas. We're really beating this chat interface over the head. It's definitely going to be here for a long time. It's going to be here to stay, but I think that there are more interesting, innovative ways that we can, build up products and also just build out really great, powerful agents underneath the hood, right? We said it a long time ago, one prompt is not enough. I think the LLM industry and the software industry is really getting into that place where we're finally starting to dig into, prompt orchestration and unlocking the power of different combinations of LLMs with our code, with our data, right? We've talked about a lot of these topics before in the past. I felt it was really important to bring these prompt chains back up and really highlight their capabilities to help you build great agentic software. As I've been digging back into working on probably one of the most important agentic applications I'm going to build, and that is my personal assistant. Let me know if you want me to share videos on how I'm thinking about designing and building my personal AI assistant. There's a lot of really interesting ideas there and a lot of really interesting concepts that we've built on the channel, and some brand new concepts that I'm still working through myself. Many of these ideas include, building great prompt workflows using several of these prompt chains. Throughout filming this video, we just finally hit the 10K mark. That's it, guys. We got 10K subs. I just want to shout out again everyone that's been following, everyone that's been getting value out of the channel. Thank you so much for watching. I really appreciate you being here. Let's continue to transform. Let's continue to evolve. Let's continue to use the best tools for the job using great engineering patterns. Let's keep thinking, planning, and building together. Let's become agentic engineers. Thanks so much for watching. I'll see you in the next one.